Hey everyone, here is the Unit 1 review sheet. Feel free to fast forward to whatever you need to look at specifically, but I'm going to work through the whole thing top to bottom, so watch along for your test on Monday. Okay, so for number 1, which function would be classified as continuous? And number 2 would be which one is discrete. So let's look at our two statements. So for Roman numeral 1, a student group is selling chocolate bars for $2 each. The function f of x equals 2x gives the money collected of selling x chocolate bars. Okay, and then for Roman numeral 2, Amanda walks at an average speed of 3.5 miles per hour. The function d of x equals 3.5x gives the distance in miles that Amanda walks in x hours. Okay, so for on number 1, we are selling chocolate bars. We are selling individual chocolate bars. So because these are individual amounts, we could sell 0 chocolate bars, we could sell 1, we could sell 2. We cannot sell, for example, 4.5. So, or we couldn't sell 5.1. So because we can't sell smaller portions of chocolate bars, this would be discrete. So Roman numeral 1, that is discrete. For the other one, we're walking 3.5 miles per hour. So we have miles, which is the distance, and hour. Those are both continuous variables. So because we could always walk a smaller amount, we could walk for 1 hour, we could walk for 4, we could walk for 7.01. It's a long time, but we could walk 7.01 hours. So since we can always take a smaller portion of the variable, this would be considered continuous. So number 2 is continuous. For the domain and range on statement 1, the domain, okay, so like we already talked about, for statement 1, we're selling chocolate bars. We could sell 0, 1, 2, sell 3, 4, 5, so on. But we can't sell negative and we can't sell half. So if you think about what kind of numbers are those, which, by the way, don't forget, we have natural numbers, and those are counting numbers, starting with 1, 2, 3, 4, 5. We have whole numbers. These are just the fancy set ways of writing them. And that's 0, 1, 2, 3, 4, 5. So the same thing as natural, but you have 0. We've got integers, and that's z. And that's basically the same thing as whole, but you could have negative as well. You could have negative 3, negative 2, negative 1, 0, 1, 2, 3. And we've got real numbers, and so that's all of the above plus decimals or fractions and such. Okay, but yes, okay, so we have the domain, and we're going to have the set of all x values where, so x was our independent variable, our chocolate bars. We could sell any x value that is a whole number. So this is x is an element of the set of whole numbers. That's the fancy way of writing x is going to be a whole number. You could also just write the w by itself if you wanted to. For the range, so we have f of x, that's our term for y, right? All f of x values where, okay, so if we sell 0 chocolate bars, we're going to make $0. If we sell 1, we're going to make 2. If we sell 2, we're going to make 4. So these are still whole numbers, so we could still say that f of x is going to be a whole number, but what's special about them is that they are multiples of 2. Then for statement 2, the domain. Okay, so x is our independent variable, set of all x values where we could walk 0 hours, we could walk 1, we could walk 3.5, we could walk 7.01, but we cannot walk a negative, so we just have to say that the x values must be, it can be any x value that is greater than or equal to 0. So it can be a decimal, it can be 0, and it can be as big as it wants to, it just can't be negative. The range will be the set of all. Here our y value is going to be called d of x. Sorry, I'm running out of room right there. But if we walked 0 hours, we would go a distance of 0 miles. So really, depending on how many hours we walked, our distance could be anything as well, it just can't be negative. whoops, shouldn't have an equal sign there. Set of all d of x values where d of x is greater than or equal to 0. Sorry, that would all be on the same line normally. Okay, let's move on. For numbers 4 and 5, using this table, we're supposed to determine if a to b and or b to a is a function. So this is where we're going to ask that question, is it true that for each a, there's only one b? For number 4, we have Klein ISD football players and jersey numbers. So let's figure out if going from a to b is a function. So is it true that for each Klein ISD football player, that's any of the high schools or middle schools, there's only one jersey number that they wear? Yeah, that works. So a to b works. And then going the other way is b to a function. Is it true that for each jersey number there's only one Klein ISD football player who wears it? No, not necessarily. Say we pick jersey number 13. Say there could be a 13 at Klein High or Klein Oak or Klein Collins or Klein Forest. So it could go either way. So b to a is not a function, only a to b. For number 5, we have Klein High varsity football players. Is it true that for each Klein High varsity football player there's only one jersey number that they wear? Yes. But going the other way, is it true that for each jersey number there's only one Klein High varsity football player who wears that jersey number? Yes, it is really specific as far as Klein High varsity football players, so yes, b to a is a function as well. So on that one we would say both are a function. Okay, for number 6 and 7 and 8, these are easy to overthink, but these are just x values. It even tells you whenever something's sitting in parentheses right there, that's just your x value. And of course f of x could be our y value, so it could g of x. So for number 6, this is an f, so we're going to use this function, whereas on 7 this is a g, so we'll use this one. But f of, don't forget, that's our x value. Go to the graph and find the y value whose x value is 2. So on my graph, here's the point that has an x value of 2, and I think, what's my y value there? It's 0. So that's it. Whereas on number 7, I understand this graph is a little bit squished, and so it's kind of hard to tell. But if we're looking at number 7, this is negative 1.5, and again, that's just our x value. So we go to negative 1.5, we go down to its y value. Its y value there is negative 1. I understand it could be also negative 1.5, but they won't always be this hard to see. So 0 and negative 1. For number 8, it tells us the domain is negative 3. Negative 3 has 0 and 2/3. These are just a bunch of x values. So all you have to do to find the range is plug in each of these x values. If you plug in negative 3 for x, then you're going to get negative 4. When you plug in negative 3/5, you'll get negative 28 over 5. And it's perfectly fine to have improper fractions as long as they're reduced. If you plug in 0, you're going to get negative 6. And when you plug in 2/3, you're going to get negative 58 over 9. And that's your answer. Okay, for 9, 10, and 11, we're supposed to state the domain and range of the given graphs in both set builder and interval notation. So on number 9, for the domain, our x values, we're looking at what x values are included. Well, it's all of them. So in set builder notation, we can write all real numbers, just like that. For interval notation, all real numbers is going from negative infinity to positive infinity. Okay, so remember in set builder you can't have infinity signs, but in interval notation you can. By the way, I guess it wouldn't really hurt if we make our little chart here, and I will draw it for you. So if our graph is pointing towards infinity or it has an open point, in set builder we'll use the less than or greater than sign, not equal to. In interval notation, we would have parentheses. But if your graph has, if it's part of the graph, there's a line there, it's not an arrow or an open circle, or it's a closed point, then we would use less than or equal to or greater than or equal to, and we would use brackets. So back to this example, our arrows pointed to infinity, so we used parentheses right next to the infinities. For the range, we are starting down here at -3 and going up to infinity. Always work from the bottom to the top, smallest to largest. So we're going to have the set of all y values where. So we're going from -3 to the infinity, but infinity cannot be in set builder notation. So all we have to write is y is greater than or equal to -3. And that implies we're going towards infinity. As far as interval notation goes, we are going from -3 again to infinity. And notice we have the equal to here because that's part of our line like we saw right here. I'm saying that's part of our line. So we're going from -3 up to infinity. But since the -3 is included in our graph, we're going to put a bracket. And infinity always gets a parentheses. On number 10, this one's a little bit different. It's just a vertical line here. So for our domain, it doesn't matter what value, what point we pick on our graph. The x value is always -4. So for the domain, we could say the set of all x values where x is equal to -4. And for interval notation, we won't say, like here we have -infinity to infinity or -3 to infinity. We're not going from one number to a different number. It's always -4 and it's always equal to -4. So we'll just put -4 inside some brackets. For the range, however, it is not constant like the domain was. So we just look at our graph, we go down 1, 2, 3, 4, 5. So we have the set of all y values where we're going from -5 up to infinity, but we don't want to write infinity in set builder. So we'll just say the y values greater than, not equal to since it's an open point like you see on your graph right there. So we'll say just greater than -5. And then in interval notation, we're going from -5 to infinity. -5 is an open circle, so that means we'll use a parentheses. And infinity also gets a parentheses. It always gets a parentheses. And then there's number 11. We have it in two pieces. So our domain and or range may be in two pieces as well. So let's just look at this. First, the domain, moving left to right. So for the domain, we have the set of all x values where. So we're going from -infinity up to -2, and then the next time we use an x value is over here at +2 to 5. So we can just write the domain in two pieces. So -infinity to -2. Remember, don't write infinity in set builder. So it's just the x values less than or equal to, since it's a closed point, -2. Then we have to say the word or, because our domain is either going to be less than or equal to -2, or it's going to be over here between 2 and 5, but not equal to since those two endpoints were open circles. In interval notation, less than or equal to -2, that means we're starting at -infinity, which always gets a parentheses. We're going up to -2, but we're including it, so it's a bracket. Then you use that union symbol. I'm running out of room, so I'm going to, well, maybe I can fit it right there. Then we jump over here. So or is the same thing as union, and we're going from 2 to 5. 2 to 5, but here they get parentheses since they are open points like our chart says. The range is easier though, because even though the domain was in two pieces, doesn't mean that the range is in two pieces. Its lowest y value is down here at 1, 2, 3, -4. And so we have -4, -3, -2, -1, 0, 1, 2. And even though this is an open circle here, the y values of above 2 are included on this side. So it goes up 2. It does go back down a little bit, but it goes up to infinity again. So as long as we're above -4, a y value is being used somewhere in our graph. Set of all y values where y is greater than, because we don't have a closed point anywhere for -4, so it's greater than -4 for set builder. And then interval notation, we're going from -4 up to infinity, both with parentheses. -4 because it's an open circle, and the infinity because it always gets a parentheses. Let's keep going. Okay, so for this part we're going to define our variables that we're using, we're going to give a function, and then describe a reasonable domain and range. So I'm just going to use x and y. Why not? So I have x will be one thing and y will be the other. Okay, so we're told about commission on his sales. So sales would be if you sold 3 items and you sold them for $10.25, and $4.75 and one for $5. Your sales would be those numbers added together, and so you get a commission on a percentage of how much you sold. So then X would be the dollar amount of the sales you made. But Y would actually be the amount of money you're bringing home. So we're not looking at how much you're earning month to month. We're just looking at how much we've earned this month. So Y would be this month's earnings. Sorry, that's messy. Okay, so for our function, we'll have Y equals, so we're getting 7% on the dollar amount of our sales. That's 0.07x, and then our constant is $1,500, so plus 1,500. Okay, so then we just need to look at our reasonable domain and range. And I'm going to use set builder notation. So for our domain, the set of all x values where, okay, so I could make $0 in sales. And let's not put a limit on myself. I could make up to infinity. So I just have to be not negative, but I can be greater than or equal to 0. Now I understand that you may think, okay, sales dollars only go out 2 decimal places. And that's true, but because between 0 and $1 we have 1 cent, 2 cent, 3 cent, and so on, we'll just say that that's close enough to being all real numbers for simplicity's sake at this point. Now if you wanted to say x is greater than or equal to 0, but x can only go out for 2 decimal places, that's fine too, but this is fine as well. Okay, so for the range, if we sell 0 amount in our sales, we're still coming home with the $1,500 per month. So even if we don't make any sales and it's a really bad month, we're still going to have at least $1,500 written on our paycheck. Okay? Then number 13, charges for riding in a taxi if you pay $3 plus 25 cents for each mile. So start out by defining our variables. I'm going to say x is our number of miles, and then y is going to be our total charges, what we owe whenever we get out of the taxi. So for our function, the amount we owe will equal, we're being charged 25 cents times our number of miles, 25 cents per mile, and then just a flat rate of getting in the taxi will cost us $3. The domain, set of all x values where. Okay, so how many miles could I go? I could go 0. Sure, I get in the taxi and I realize I'm already there and I get back out. So I could go 0 miles. So x could be greater than or equal to 0, right? It just can't be negative. And it doesn't matter if it's whole numbers or whatever, because I can go half a mile, I can go a quarter of a mile, I can go 3/4 of a mile. So pretty much anything greater than or equal to 0 is possible. For the range, set of all y values where. So if I don't go any miles at all, how much am I still going to owe? $3. Because maybe the taxi driver missed another potential customer. So we still owe $3, so the amount we owe still is going to be greater than or equal to $3, but it could go up from there depending on how far we drive. Don't forget to review these worksheets, and I will post somewhere. I will try to get those answer keys online somewhere. Just be a little patient. I'm getting used to our new website. Okay. And then our last section, we've got compound inequalities, and I use the number lines on these. Just so you know, it doesn't matter if you want to use your number line or not, but I think it helps to simplify and it prevents silly mistakes. So first of all, let's go ahead and solve each part for x. So if I divide this side, this first one by 4 on each side, I'm going to get x is less than 3. Over here, if I divide by -3, don't forget when you divide or multiply by a negative number only, you're going to switch the sign. So now we have -5. But we have this word and here. So if we start out by drawing our number line, we've got -5 is smaller and then 3 is bigger. Okay, so at 3, we're going to have less than 3. So here's open circle, it's not equal to, and then we're going to go less than 3. But then we also have and x is greater than -5. So if we do, say, purple. Okay, so we have -5, there's going to be an open circle, but we're going to go greater than -5. That's going this way. So and actually just looks at where it overlaps, which turns out is right in here. So our answer will be this in-between thing. -5 is less than x is less than 3. So remember, and is picky. It only wants where it overlaps. Well, let's look at the next one. So we subtract 3 from both sides. We get x is greater than 4. And here we'll divide by 2. Don't switch the sign because 2 is a positive number. So we have x is greater than 6. Draw our number line. Smaller number is 4. The larger one is 6. So first of all, x is greater than 4. So it's an open circle because it's not equal to, but we're going to go greater than 4. Then we have x is greater than 6. So we have an open circle at 6, whoops, open circle at 6, and then greater than 6. The difference between or and compound inequalities. And only wants where it overlaps, but or wants to include everything that got shaded. So anything that got shaded on here was this whole region right there, and we can describe that section by x is greater than 4. So that's our answer for that one. Letter C, start out by subtracting 5. We get 3x is less than 3. Divided by 3, you get x is less than 1. Over here, subtract 6. We get 5x is greater than 10. Divided by 5, you get x is greater than 2. Do my little number line. 1 is smaller than 2. So I've got x is less than 1. So right there. We've got x is greater than 2. So open circle on the 2, and then greater than 2. So notice that these two don't overlap at all, but that doesn't matter with or. Or wants to include everything that got shaded. So that was this part and this part. So we want to include both of those in our answer. So all we have to do is just write them down, the smallest one first and the largest one. X values less than 1 or x values greater than 2. So or you can actually still have the word in your answer, but and will never be in your final answer. Letter D, divided by 2, you get x is greater than 3. For the other side, divided by 3, you get x is less than 5. Draw a little number line. We've got 3 and 5. So we have x is greater than 3. X is greater than 3. And we've got x is less than 5. X is less than 5. Okay, but or wants to include everything that was shaded. Well, that's the whole number line. So our final answer will be everything. In other words, all real numbers. All real numbers can only occur when you have or. Looking at E, divided by 2, you get x is less than -4. Divided by -5, you got to switch the sign. We get x is greater than 2. Drawing our number line, -4 is smaller than 2. So we have x is less than -4, so an open circle there because it's not equal to. Got less than -4. And then x is greater than 2. So x is greater than 2. We're looking for and we're looking for that overlapping region. Well, it doesn't look like that ever happens here. So you could either write out no real solution, or you can do it like this as well. That's the empty set. Okay, and then last one, drawing our number line. Oops, getting ahead of myself. Okay, first of all, let's solve. Subtract 3, get x is greater than 6. And then on the other one, subtract 2, you get negative x is less than 2. Divide it by negative 1, and you'll get x is greater than negative 2. Now we can do our number line. So here, negative 2 is less than 6. So we're looking at x is greater than 6, so there's an open circle on 6, and greater than 6. And then x is greater than negative 2, so there's our negative 2, greater than negative 2, and then remember, and is where they overlap, and that's just this part over here, and we describe that by x is greater than 6. Alright, well I hope that helped you. Feel free to check out the other videos that I have posted on my channel. They are from last year, so if I'm saying random things about turning in papers, you can just ignore that. But enjoy, good luck on your test, and have a great weekend. Bye!